I'll go directly to example number 4. So in this particular example, we still have two sets of masses. However, in this particular case, we're given the value of the acceleration. So just the magnitude of the acceleration. And what would be the mass of block A if the pulley system accelerates at 2 meters per second when B has a mass of 5 kilograms. So we're just given the mass of B. So this is a variation of this type of problem. Okay, we're given the acceleration, but we don't know the mass of our object A or block A. So essentially, we don't know MA here. That's a question mark, but we're given the value of MB, which is 5.0 kilograms. So in this particular case, by just looking at the situation, the magnitude of the acceleration is given. However, we're not really, or it's not mentioned in which direction, but by just looking at this one, the acceleration should be in the clockwise direction also. So this should be in the clockwise. So that means that the acceleration of my A would be to the right, and the acceleration of my B is to downward. Okay. So therefore, I'm gonna set to the right as positive, down as positive for my B. So just like what I did in the first one, I'm gonna start with the free body diagram of both A, again separately, and B. Okay, so I'm gonna draw the free body diagram of both A and B. Again, for A, so it's lying horizontally on a surface. So again, there should be weight of my A, and there should be normal force because again, it is lying on a surface. So the vertically, there's also a force that is upward. This is my Fn. And in this particular case, the acceleration is just along x. So therefore, this normal force should be equivalent to FGA. And it doesn't affect the normal force, and FGA doesn't affect my horizontal motion. So in this particular case, again, it is assumed that it is in the horizontal or in a frictionless surface. So the one that will make your object move or object A move to the right is the tension force, okay, represented by Ft. Now, if I'm gonna look my object B, and again, in this particular case, I'm gonna make use, since the acceleration is to the right, so I'm gonna make to the right as my positive direction. So in my object B this time, so if I can examine the forces, there's a force going upwards, which is the tension, because that is here. This is the tension force. Okay, but this time it's moving up. Remember, that's how we define tension. Tension is parallel and away to the application of the force. In this case, again, we're looking at B. So therefore, tension force is upward in this case. And you have the weight of the object. Again, this is just the gravitational pull of the Earth. And the weight, the mass, or the magnitude of the weight is given by its mass times G. So since I've given the mass of, was given the mass of my B, so I'm just gonna solve that one out. So 5 times 9.8. So the magnitude of my weight is given as, what's the weight of this? This is 49. So 49 newtons. And then again, just to, even though I've written that one, that A is downward, the acceleration is downward. So that means that I'm going to set my downward as my positive direction. So now I'm going to set up the net forces. So again, since this is accelerating, so for Pauli problem, so that means that you're going to employ the second Newton's law. So the second Newton's law tells you that the net force acting on the object, so in this case A, is just equivalent to its mass, so mass of A times its acceleration. And if you can see again, the acceleration only happens on the horizontal one. And in this case, there's only one force that is lying on the horizontal surface. Again, the acceleration is just to the right. So that means that the force that affects your movement horizontally is just Ft. Again, there's no motion vertically. So acceleration there is 0. So net force there is 0. So actually, F net on A is just due to Ft. So that would be Ft. Again, it's just Ft is equal to the mass of A times the acceleration. Well, if you can see here, acceleration is given at 2. So you can have Ft. Remember that I don't know the value of Ft yet, so I'll just remain that one as Ft is equal to, I don't know the value of Ma as well, so therefore I just gonna remain that one as Ma. But acceleration is given as 2 meters per second. So I have the expression for my Ft is equal to 2 times the mass of my first object. So that is my Ft. So I'm creating my first equation here. Okay? But then again, that's not enough because Ft is an unknown quantity as well as Ma. Although take note that I'm trying to solve for my my Ma. However, I can also create another equation from my object B, because F net on B is equal to MB times A. Again, since the object B will also be accelerating, but its acceleration is along this vertical line, the vertical line, it's going down. So that would be MB times A. F net on B, if you can see, I have two forces, Ft and Fgb, where in Fgb, the magnitude of Fgb is known. So that would be Fgb, and again, that's positive, so a positive direction, so plus Fgb, and then minus or plus the negative of Ft. Again, that's negative because, again, I set my downward direction as my positive, and that would be MB times A. So I'm just going to substitute anything that I have. So FGB, I was able to compute for the weight of object B as well as A is given. So FGB is 49 minus FT is equal to MB is given, which is 5. So therefore, I also have the value of MB, which is 5. It's given 5 kilograms, then multiplied by the value of A of 2. So you have that value there. Okay. So I'm just gonna again combine any similar terms. So this is 49 minus Ft is equal to 10. So in this particular case, I can already solve for Ft. So is it not that this is just the magnitude of my tension force in this case is given as, so if I gonna transpose this one to the other side, this gives me Ft is equal to 49 minus 10. Okay, so just algebra, transposing this to the other side, that gives me negative 10. This one gives me that. And Ft, therefore, I have the magnitude for my Ft. Ft is given as equal to 39 newtons. Okay? So if Ft is 39 newtons, that means that I can use my equation number one. So I'm just gonna substitute this value. So just substitute this value. Oops. Uh, so just substitute this value to here. Okay. So I'm just gonna write it out. Substitute Ft is equal to 39 to equation 1, okay, to your first equation. So again, the first equation has the equation of Ft is equal to 2ma. So if I gonna do that, if I gonna substitute my Ft, that means that I gonna write 39 newtons is equal to 2ma. So now I'm just gonna divide both sides. I'm solving for ma in this case. So divided by 2, uh, ma will give me, that would be 19.5. However, in two significant digits, ma is around 2.0 times 10 to the power of 1 kilograms. Okay, so the mass of your first object must be 20 kilograms. So any question with this one here?
Yes, teacher.
Yes.
So now I'm not really understand what is F net mean.
F net is, oh, this is going back to our first and second Newton's law, right? Net force. F net means sum of all forces acting on an object. So you just take the sum. So it's the sum of all the forces acting on an object. So if you can see here, for object A, even though if I'm gonna write again, the free body diagram tells you, the free body diagram
Yes,
will give you all the forces.
but I find more easier way to do this question.
Yeah, if you,
Yeah,
as long
like
as it's mathematically correct
yeah,
and
like
you have shown how did you get that one,
like
it's fine with me. But then again,
mm, yeah,
yeah, I mentioned about earlier that some other books will give you a shortcut, but I
yeah.
just it like, if you're gonna learn this one, it's a good practice because how,
Mm-hmm.
if you know have several, if you have friction there, it would be very confusing. Like if you're gonna just do it in one setting,
Yeah,
because essentially the shortcut equation that was given to you is also taken from this individually. Again, you start,
yeah,
if you're talking about net force, it's the sum of all the forces acting on a particular object.
yeah.
Yes.
So I think when we do these questions, we can we can see that Fg of the object B is actually equals to Ft, right?
What?
The the gravity of the object B is equal to Ft, right?
No,
Nope.
because they are equal. Yeah, if they are equal, it will not be accelerating, correct?
Oh yeah. Oh, okay. I understand.
So therefore, FGB should be bigger compared to your FT, because
Okay.
if they're equal, that means that maybe it's still moving, but
Yeah.
it will be moving at a constant
Yeah.
velocity.
Yeah. Okay. I understand.
Yes. Yeah. So therefore, the FT there should be, the magnitude is less than. The magnitude of your FT is less than. But then again, if you can see, if
Yeah.
you can combine A and B here, you might be confused yourself. Why is that FT is to the right?
Yeah.
The other one is upward. Well,
Yeah.
again, anyway, when you're talking about taking the sum of all the forces, you're just examining each object. So that's why I try to separate the free body diagram of my A and my B. And on my A, I'm just concentrating on the horizontal forces because your acceleration only happens on the horizontal component. Because actually, just like in the previous example, you don't have any no vertical movement. So that means that AY in this case is 0. So that means that the acceleration, the 2 meters per second there is only for the horizontal part. You don't have any vertical part. Okay. Any other questions? We can proceed to, yeah, example number 5. Again, I'll be giving you the solution also of this, um, because you'll be having 3 sets of equation here. Acceleration would be the same, but if you can observe, the tension at this side is different at the tension on the other side. So actually, it's no longer just FT, but you can have FT1. If I'm gonna call this one FT1, and this one here is FT2. So these two values, I'm using different subscript because these two are have different magnitudes essentially. So FT2 here is due to this, and FT1 is from here. Okay, so if you can see, you have FT1 and FT2, as well as the different, well, you need to determine MB. So basically you have 3 unknowns here, but you can also create, because you have 3 objects, so you can create 3 equations. Okay, but again, we just go directly to example number 6. Again, for the notes that I'll be sending you, I'll be including the solution for example number 5 as example number 3. So let's do this other example here. So there are only 2 types of questions that I'll be asking you. It's either solving for the acceleration or getting the mass of one of the object. Okay, so in this particular case here, we're given already that the acceleration is 1.6 clockwise. So clockwise direction is the motion of your clock, right? So that means that the acceleration is this way, okay? Because it's clockwise. So clockwise is rotation here. So that's clockwise. So that means that uh, the object So you have to be careful here. You need to follow the what is written in the given. So clockwise is in that direction. So that means that the acceleration of your unknown m, the acceleration would be, it will be going up. So therefore, I'm gonna set that one as positive. And the other side, this object here would be moving downward. So its acceleration is down. So I'm gonna take that one as positive. Okay. However, same thing as before, I'm gonna draw the free body diagram for both. But there's one thing that I want you to take note. Remember that I mentioned last time that in order for us to use without necessarily writing all the units in our solution, we must be careful that the given quantities must be in the correct units also. Like for example, for Newton, Newton is the unit when the mass is in kilogram and the uh, acceleration is in meters per second squared. So therefore, mass should be given in kilogram. And if you can see here, m is given as grams. So before anything else, try to convert that one to kilogram. And that is equivalent to 0.25 kilogram. Okay? Because 1 kilo is just 1,000 kilograms. So m, small m, is therefore 0.25 kilogram for a while. Okay, sorry for that. So again, if you can encounter anything, Newton is created for mass. Mass is given in kilogram, and the acceleration is in meters per second squared. So I see a mass given in gram. So I'm gonna convert that one to kilogram first. Okay. So now I'm gonna draw my free body diagram. Again, the free body diagram of capital M and small m. Okay. So I'm gonna draw. So of course, capital M. So if this is my capital M, well, it is attached to a string, so therefore that should be tension force. Remember that it's not normal force, because normal force, there should be a surface to an object lying on a particular surface. But in this case, you have a string being attached, so that would be Ft. And you have here Fg capital M, okay? And the expression for Fg capital M is just capital M times 9.8. So therefore, the weight, or Fg capital M, is just 9.8 times capital M. Remember, I don't know yet the mass of block A, or that capital M. So I know that, again, this would be moving in the clockwise direction. So clockwise. So that means that the acceleration here would be upward. That's the plus direction. Okay? That's a plus direction going up. Now, looking at my object B. Object B is small m. Okay? So small m. So what are the forces acting on my small m? Well, you have here Fg small m, which is equivalent to small m times g, but I've given the value of small m, that's 0.25. Again, you need to convert because the standard unit of weight or force is Newton, okay? And Newton is, again, a result from kilogram multiplied to meters per second squared. So I'll get here Fg small m is equal to around 2.45. Again, I'm not rounding off anything yet here. And I know that there must be tension upward. But then again, due to specifically, I was given the direction that it is clockwise. That means that small m will be moving downward. So that means that I'll be setting my direction of my acceleration to be positive going downward. So anything, so in my coordinate here for my direction, downward is the positive direction. Okay. So now I'm gonna go to my application of my second Newton's law. So both would be accelerating. So that means that the net force in my capital M is just the capital M times the acceleration. Okay. So now I will look at my small m. Small m is this one. So what are the forces on my capital M? It is given by Ft and Fg capital M. So going upward is positive, so therefore this is Ft. Then plus the negative of the magnitude of Fg capital M is equal to capital M times A. Okay, so now in the problem A is given. So again, the next step will just be just substituting anything, the things that I know. Well, FGM in terms of capital M is given by that. Again, that is given here. FGM is given by that. So therefore, I just replace my FGM with 9.8 capital M is equal to capital M multiplied by 1.6. So therefore, I can get an expression from my object capital M. I can set an equation of negative 9.8 M is equal to 1.6 capital M. Okay. And if you can see, I can get an expression for my Ft. Ft is just equivalent to, well, if I'm gonna add both by 9.8 M plus 9.8 M, remember that both have the coefficient or the variable of M. So therefore, these two are what you call similar terms. Similar terms can be added. So that should give me an answer of 4. That's 11.4 capital M. So Ft, from my first object, I get the expression for my Ft equivalent to 11.4 times capital M. And again, this would be my first equation. And from this equation here, I cannot solve for either Ft or capital M. Although remember, I'll be solving for capital M in this case. Because again, one equation, I have two unknowns. But then again, for my second object, so I'm gonna look at what are the forces acting on my small m. And again, the net force there is just equivalent to its mass times its acceleration. So what are the forces on my small m? Well, I'm gonna go to my free body diagram. So the free body diagram will tell me, or at least show me, all the forces acting on the object. And if you can see, it's only given by Ft and Fgm. Fgm is given because I know the acceleration and the mass. Okay, so now, again, I set my acceleration here. I know that the direction of the acceleration is downward. So I set downward as my positive direction. So this should be Fgm plus the negative of Ft. Again, Ft in this case is upward. So it's in the opposite direction of the positive direction that I set. Again, it was already set in the question. The acceleration of my m, small m, is downward. So I'm gonna set that one as my positive direction. And this is equivalent to small m times a. So I'm just gonna substitute everything that I know. Fgm is known, and that is 2.45. Then minus Ft, and that is equal to the mass small m, that's 0.25. Again, it's very important for you to convert your gram to kilogram in this case, because you might get a different answer. Well, obviously you will get a different answer if you did not do that. This is 0.25 times. What is the acceleration? It's 1.6. Okay, it's given. Acceleration is given by 1.6. Remember, this is different. This is A. It's different from G. G is a constant. So G is being used if you want to get the weight. Okay, the magnitude of the weight. But for for the second Newton's law, you're talking about the acceleration of the object itself. So this object is accelerating at 1.6 meters per second. So that's 1.6. So 2.45 minus Ft. And just get the product of 0.25 and 1.6. So that should give you an answer of 0.4. Okay. And if you can see, is it okay? FGFT. Okay. So if you can see here, actually I can solve for the value of my FT. So I'm just gonna subtract both by 2.45 minus 2.45. So negative Ft is equal to, this should be negative, that's 2.4, right? Negative 2.05, correct? And then, or the magnitude of my Ft is just equivalent to 2.05 Newton. So if you can see, I can use this one to substitute here to solve for my capital M. So using equation 1 and substituting value of Ft is equal to 2.05 to that, you can solve for your value of M. Again, Ft is given by 11.4 capital M. So if I'm gonna substitute this to here, that should give me 2.05 is equal to 11.4 capital M. So I'll be dividing both by 11.4 to solve for M. So capital M should be equivalent to, just gonna calculate this one, should be 2.05 divided by 11.4. So how many sig figs given is 2 and 2. So this should be around 0.18 kilogram. As to be expected, the weight or the mass of your capital M should be lesser. That's around 180 grams. The other one is 250 grams. So if it will be rotating clockwise, so that means that uh, remember the tension of your object here would be bigger in the other side, or this should be bigger compared to the other mass. Okay, so any questions?